First one, you gotta find two numbers that multiply to 7 but add to 8. 1 and 7. Check it. 1 times 7 is 7. 1 plus 7 is 8. That works. The next one, two numbers that multiply to positive 10, negative 1 and negative 10 do multiply to positive 10. And they also add to negative 11. When you add two negatives, you get another negative. Awesome. And then the last one, two numbers that multiply to negative 90, but add to 1. I thought, like, looking at this one initially, it looks really hard, but it's actually pretty easy if you figure it out. So here we go. 10 and negative 9 multiply to give us negative 90. And then they add to give us positive 1. All right, good. So those are the correct values that you should have on your magic squares. And so we use magic squares. Why am I saying squares? Magic X's, sorry. We use magic X's when we are trying to factor a quadratic trinomial. Okay, we put the constant at the top, coefficient of the middle term at the bottom. And then once you have these numbers, then you can easily write out the factored expression. So like for the first one, this would just be b plus 7 times b plus 1. For the next one, you would have n minus 1 times n minus 10. For the last one, you would have m plus 10 times m minus 9. Now, you didn't have to do that for this warm-up, but that's how you use this magic X to factor these expressions. And so what we're going to look at today is solving equations by completing the square. We're going to learn what it means to complete the square. And your learning goal is I can solve quadratic equations by completing the square. So we do want to look at the definition of something here. This is a perfect square trinomial. So remember, a trinomial is a polynomial with 3 terms. And so a squared plus 2ab plus b squared is a trinomial, has 3 terms, but it's also a perfect square trinomial because its factored form is equal to a plus b times a plus b, which is a binomial that repeats. And so we get the square of a binomial, a plus b squared. Now, these types of trinomials are easier to factor because they're a special case where we can just jump right to this without having to use a magic X and without having to use the bottom-up method. The other perfect square trinomial form is a squared minus 2ab plus b squared. Now, a and b are just numbers, okay? They could also be variables. This factors to a minus b times a minus b. It's the same binomial, so we can rewrite it as the square of a binomial, a minus b squared. I have 2 copies of the same thing. So this is the very general form. Some worked out examples here. So x squared plus 12x plus 36. This is a perfect square trinomial. And we can, think about 12 as being a product of 2 with something else. Okay, 2 is 6. And that something else, that 6, can be another way of writing 36 if I square it. 6 squared is 36. 2 times 6 is 12. And so the a and the b that I have here, a happens to be just x. It shows up here, and it shows up here. B happens to be 6. So when I write the square of the binomial, it's just a plus b squared, x plus 6 squared. I didn't have to use a magic X to do this. It's a special case because 6 plus 6 is 12, and 6 times 6 is 36. There's also this example. 9x squared minus 12x plus 4. So if you look at these and you think about, is there a way to rewrite it when you see perfect squares show up, like 9 and 4? If you rewrite those as the square of their integer, 9 is the same as 3 squared. So 9x squared is the same as 3x to the second power. 3x is the a in this case, which also shows up in the middle term. Noticing that's 3 times 2. I think that's a typo. That should be 3 times 4, right? Not crazy. That's 6. That's weird. Why did they do that? Am I missing something? You guys see that? 3 times 2, that's 6. Why is this 12? Why is this 6? 2 squared is 4. I think that's a typo. Okay, I think this is supposed to be a 6 right here, because otherwise that doesn't make sense. Okay, so that's 6. Imagine that as a 6. I'll have to change that. That's weird. 3x minus 2. So 3x is the a, 2 is what we're squaring. That is the b. This should be a 6. I can't write on that side to change it. Okay, well, the process that we're doing today is called completing the square, which is a process of rewriting a quadratic expression as a perfect square trinomial so that it can be solved by taking square roots. So here we have x squared plus bx. If you visualize x squared as like an algebra tile, it's a square with x as the side lengths. Bx as an algebra tile would have the same length of x, but then its width is b. And then I can take this right here and change the way bx looks. I can split b in half, which would cut this piece in half. And then I have one rectangle here, but then I move one rectangle down here. And then if I'm trying to make an entire large square, I'm just missing one piece. I'm missing a piece that would go right here. And the size of that piece is length and width of b over 2, because that's what this is and that's what that is. So its area would be b over 2 squared. I'm showing you this because this is what we're going to be using to complete the square. We're going to be taking b, dividing by 2, and then squaring it. B is just a number that will divide by 2 and then square. So we have an amount that we can use to complete the square algebraically. So this first slide that we're going to do some problems on, these are the steps for it. We are completing the square for an expression by first identifying what is b. B is going to be the coefficient of the middle x term. And then 2, we're going to find the value of b divided by 2, then squared. That's just a number. Once we figure it out, we just add it to the expression, and that completes the square. So for this example, x squared minus 8x. We're going to go through those 3 steps that you just seen. So the first step, identify b. This is step 1. And b is just equal to whatever the coefficient of that x term is. In this case, it's negative 8. If you don't see why it's negative 8, you could always rewrite the given expression as x squared plus negative 8. Okay, it's the same thing. So if you don't see where the negative 8 came from, think of this as adding the opposite. So now that I know what b is, we're going to put that in the box. So in the box, we're going to put b equals -8. Now we're ready for step 2. We're going to find what b divided by 2 squared is. Which means instead of b, I'm going to put -8. And then I want to simplify this expression right here. What is -8 divided by 2? You always do what's in the parentheses before you do exponents. That's PEMDAS order. Yeah, -4. -8 divided by 2 is going to be -4. And then the last step is to square -4. How much is -4 squared? -4 times -4.
8. No, wait, 16.
Yeah, 16.
So,
No, you're not. You're fine. 16. Okay. So we found what this is equal to. This is the number I'm going to then add to my expression, my original expression. And that's the third step. Step 3, we're just going to add 16 right here. And we've now completed the square, which means we've set it up so that it's a perfect square trinomial. And it's now easily factorable using what we had as examples a little bit further back. So I'm going to leave you right here on this slide. I'm not going to force you to leave. I'm going to come back here and show you. So we're right here with this a squared minus 2ab plus b squared form. And so we can rewrite this trinomial that we have as a minus b squared, which is, now when you say b, this is a different b they're talking about. They want to know, what did you square to get 16? Well, it was -4, so. So x is your a minus b, but it's not the b in this problem, it's the b from the previous slide, which basically just means, what did you square to get 16? Well, you squared -4. That's why there's -4 right there. And squared symbol. Okay, so the factor form of that one would be x minus 4 squared. So see if you can kind of do this with this other one. X squared plus 12x. If you go through these 3 steps, what is b? What's the coefficient of the x term? And you're going to take it, divide it by 2, and square it. Well, you can start it. I'll do it with you in a second. But you can start it. And I'll go over it. Do as much as you can before you get stuck. Or do the whole thing, which would be best. So this person's figured out that b is 12, good. And then they are dividing it by 2 and squaring it to get 36, awesome.
Did I get it right?
I don't know whose I'm looking at as I'm going through this.
You want to watch it? much smarter. I'll have to carve something out.
All right, so you guys are doing good. And if you're a little bit lost, let's go over it. So your first step, step one, is to figure out what does B equal? And B equals 12. Your second step is to take that number, 12, divide it by 2, and then square it. Which is this, 12 divided by 2 is 6. And 6 squared is, as you can see, we were coming up with 36. Last step here is to just take that number and add it to your original expression. Okay, and that's completing the square. So the reason why we would want to complete the square is that if we're solving an equation and we want to factor it, well, we can complete the square as a way to get to a way of factoring it easily.
So the factor form x plus 6.
That's right. Yeah. So that one you want to change to, I think this person accidentally is using the other one on the other side. Yeah, so if this was something I wanted to factor now, because of what did I square to get 36? Well, I squared 6 to get 36. So the factored form, if I wanted to write it out, is x plus 6, the second power. And you can check that too, because say you did make a magic x and you wanted to factor this trinomial. 36 will go at the top of your magic x, 12 will go at the bottom, and 6, it's like a special case. 6 times 6 is 36, but 6 plus 6 is 12. So this is one of these special cases where you get the square of a binomial. So we're going to take this and we're going to look at how we can use that to solve an equation now. So there's some steps here for solving a quadratic equation by completing the square. Step 1 and 2 today, we don't have to worry about because they're already done for us. So we're just going to start on step 3 today, and then we'll look at a more difficult problem tomorrow when we come back. But we're just going to start on step 3 today. So we're going to complete the square on the left side of the equation and balance this by adding the same value to the right side of the equation. You'll get something that looks like this, which can be solved by what we were learning about on Monday and Tuesday. You take the square root of both sides, subtract the number that remains on the left side of the equation, and you find x. This sets up 2 equations for you. So in this example, right, I'm going to put you on stop, stand, face, so you guys are on the same slide as me. So in this example A, this is the equation. X squared minus 4x equals 3. So steps 1 and 2 that I just showed you are already done for us. We don't have to worry about it. So we're just going to jump right into step 3, which is to complete the square. And the way we do that is we're just looking at the left side of the equation, x squared minus 4x. We figure out b. B is negative 4. So negative 4 divided by 2 squared turns out to be 4. So that's what I'm going to add to both sides of the equation. Now, when we were doing this before, we only added it to the expression. But now that we have an equation, we have to keep the equation in balance. So if I add 4 to the left side, then I have to add 4 to the right side as well. And that's something that, you know, you can do wherever you want to equation, basically. As long as you do the same thing to both sides. So we're adding 4 here and we're adding 4 here. And the reason we chose 4 is because now this is factorable as a perfect square trinomial. X, and we squared -2 to get 4 because -4 divided by 2 is -2. So that's why -2 goes right here. Okay, we added the 3 and 4 on the right side to get 7. This right here is something that we were solving on Monday and Tuesday. Take the square root of both sides. X minus 2 equals positive negative square root of 7. Split it into 2 equations. X minus 2 equals positive square root of 7. X minus 2 equals negative square root of 7. And then you just solve by adding 2 and adding 2 to both sides. So there's 2 answers for X. And we have solved this using completing the square. So we're going to try this now. This is a scaffolded example. We have x squared plus 16x equals 36. All right. And so again, if you look back at those steps, steps 1 and 2 are done. We're jumping right into step 3, which is to just look at the left-hand side and complete the square. X squared plus 16x. I'm going to add something so that I can then turn this into a perfect square trinomial. The thing I'm going to add, well, we got to figure it out. We got to figure out what it is. So
This one's a bit more confusing.
it's okay. B is equal to the coefficient of the x term, which is 16. Right. So then we're going to put 16 divided by 2 in parentheses. And we're going to square this. To see what we get. So right here, this is where the, oh, you can't see that at all. Change the size of that. Okay, so right here, this is our B. And so we just plug it in, 16 divided by 2, and we square it. It does help to kind of go and show what you get in between. So 16 divided by 2 is that? That's 16 divided by 2.
16 divided by 2.
8. So we have 8 in the parentheses, and 8 is being squared. And then we would square 8 to get what we're going to add to both sides. What is 8 squared?
Like 70, no.
Lower.
64?
Mm-hmm.
You're
64. Okay. So now we know what we're going to add to both sides, and that's 64 that we're going to add to both sides. So this is all scaffolded, all these little boxes. You have your x squared term. They put a box in front of the x squared term, but when you don't see a coefficient there, it's really just that invisible one. Okay, so if you want to think of it that way, you can. There is a 1 right here. And then this box, we still have 16 here. And then how much are we adding to each side? 64. And this box here is the other thing that was already in our equation, which is 36. Okay. So we just completed the square, which of these new steps, this is step 3. This next part is also a part of step 3. Okay, because this x squared plus 16x plus 64 is a perfect square trinomial, we can now fill in the values here. So the x term has a coefficient of 1. And what did we square to get 64?
Oh,
8. So 8 is going to go right here. And then I want to simplify the right-hand side. We need to add 36 and 64 together now. So we want to add these two numbers. See what you guys are coming up with. Following along great. Next step, add 36 plus 64 and put it in this box. Good. 100.
oh, good. Great.
So when you're working with square roots and perfect squares, whenever a perfect square shows up, that's a good sign because those are easier to take the square root of. They're just integer answers. And we are going to take the square root of both sides, okay, like we were practicing on Monday and Tuesday. So the square root of the quantity 1x plus 8 squared is just 1x plus 8. And then we have positive and negative. What is the square root of 100? The perfect square.
We're gonna.
You have to think, what number times itself gives you 100?
10 times 10.
Yeah, you're right, 10. So 10 is our perfect square here. And notice we have positive and negative because whenever you take the square root of a variable, we need to add that plus minus in. And so now we can split this into 2 equations, 2 possibilities, the possibility where we have positive 10 and the possibility where we have negative 10. And then we just have to solve each equation. These are one-step equations. You have like terms. 8 and 10 on the equation on the left, those are like terms. So we want to get them together. The x term is on the left, so we'll move the 8 to the right by subtracting 8. Subtracting 8. When we solve the other equation, we will also subtract 8 from both sides. So if you simplify that, these cancel, and you're left with x is equal to what? What are these two numbers here? 2. Yep, 2 is one of them. 10 minus 8 is 2.
another one would be like
Negative something.
20,
Negative what?
Two.
No,
Negative 18.
negative 18. Yeah. So when you add two negative numbers, which is essentially what we're doing, negative 10 minus 8, you add their absolute values and you keep it negative. Okay, and then we have our two answers. Okay, so I'll put you on stamp pace. There's one problem for you to try. I want you to try as much as you can of it that you can do.
Which one?
It's slide 10. It's x squared minus 10x equals 11. It's set up just like the one we just did together, right? You have x squared plus the x term, and then on the other side, equal sign, you have a number. So you're going through the same basic idea here, just the numbers are different.
I think it's always gonna be the number in the middle, right?
The x term. So there's lots of different scenarios. Like say you had a bunch of terms all listed out. You'd have to combine all your like terms to get that single x term and then take its coefficient.